All right, so this first question is related to the discussion question from the second part of today's questions on Google Classroom, and the piece of information that you needed in order to answer the question has been filled in. So we're talking about the 24 students in a classroom, and again, the probability of selecting a student at random who has glasses is 13 out of 24. So that lines up with the number of students in the class, which makes a lot of sense. Now we know there are 13 students, right? If the probability is given and the denominator is the total number of students, then this tells me exactly how many students there are that meet that criteria. So 13 of them have glasses, and the probability of selecting a student at random who takes the subway to school is 5/6. And so I'm going to just pause for a second and turn that into a fraction that gives us a number of students. Because we're noticing here that 13 out of 24 and 5 out of 6 don't have the same denominator, so those are going to be difficult fractions to compare until they do have the same denominator. So what I'm going to do is try to take 5/6 and rewrite it so that it has a denominator of 24. Because if I know there are 24 students in the class, then this will tell me how many of those students take the subway to school. All right, so 6 times 4 gives me 24, and 5 times 4 gives me 20. So now I know that 20 students take the subway to school, and 13 students wear glasses. Then we're told that the probability of selecting a student who wears glasses and takes the subway is 1/2. And again, we're given a fraction that doesn't have the same denominator as the other two fractions. So I'm going to rewrite this. This is just me doing a little bit of work to make these fractions make more sense. And so that's going to be times 12, 12/24. All right, so here's what we know right now. We know that the probability of, say, glasses is 13/24. The probability of the subway is 20/24. And I know that the probability of glasses intersection subway, because those are the people who do both, is 12/24. What is the probability that a student in this class wears glasses or takes the subway to school? So what I'm going to do is sketch a little Venn diagram here, because we're focusing on diagrams in this part of our notes, and figure out what number goes in each of these sections. So this is G and this is S, right? These are the kids who have glasses over here, and these are the kids who ride the subway over here. And one thing that we know, and the place we want to start with, is the intersection. I know that 12 of these students do both, so I'm going to put 12 there. That's 12 students. And here's what we want to be careful of. If I'm figuring out how many students go into this portion of the glasses part of the Venn diagram, I can't put a 13 there because it says that 13 kids have glasses. If I put a 13 there, then 13 plus 12 will be 25 students that have glasses. So what I need is for all of these numbers to add up to 13, because remember, these 12 are included in that number. So then the number that I need to put in this portion is a 1. Because when I do that, I've figured out that 12 plus 1 gives me the 13 that I need to set up this portion of the Venn diagram, all the students who wear glasses. Now remember, these 12 are included over here. They're also included over here. So when I want to write down the number of students who take the subway, I have to do that subtraction as well. I can't put a 20 there. Even though it says that 20 students take the subway, if I put a 20 there, that's going to mean that 32 students take the subway because these 12 count as a part of this circle. So I'm going to have to subtract that 12 from 20 and put an 8 there. So now I've set up my Venn diagram so that I can see that there are 20 students who ride the subway, which is what we figured out, and there are 13 students who wear glasses and 12 who do both. So now it's easy to see what the question was asking. The question wants us to find out the probability that a student wears glasses or takes the subway. And again, that's going to be out of 24 because there are 24 students in the class. And now all I have to do is add up these numbers. I've got 1 plus 12 plus 8, which is 21. So now I know that there are 21 students who either wear glasses or take the subway to school, and you should reduce that fraction. Both 21 and 24 are divisible by 3, 7/8. So the probability that a student does either G or S is 7/8, and you do want to reduce that. And just taking this a little further with this second example, consider the events A and B, and it doesn't even matter what they are. A is something, and B is something completely different. Some event, whatever it is. And we've been given the probabilities of these two events. So the probability of A taking place is 7/10. The probability of B taking place is 3/10. And we've been given the probability of the union of these two events. In other words, the probability of A or B. Now, this doesn't have the same denominator as the one earlier, so I'm going to want to do a little work here. 4/5, and I'm going to want to turn this into a fraction with the same denominator as these two events. So that'll be 10 times 2 times 2, 8/10. And we want to calculate the probability of the intersection. So this is kind of like going backwards with our Venn diagram. If I've got the Venn diagram here with A and B being these two circles in the Venn diagram, I know that in all of A, I need to end up with a 7. So this whole thing has to end up being 7 elements. And this whole thing has to end up being 3 elements. I want to know what number of those elements go in here. But another thing that I know is that in this whole diagram, the whole picture, I have 8 elements. Because it says that the probability of A or B is 8. So I'm going to have 7 elements in here. Some of them will be shared in B, and 3 elements in here. And all of these 3 numbers have to add up to 8. So I'm just going to test some numbers right now. You might have even figured this out already. But let's try doing 7 and 3 with no numbers in the middle. Right? Maybe that's the situation. If I add those up, and I have 7 plus 0 plus 3, I get 10, not 8. So that can't be it. So it's not 7, 0, and 3. All right, let's try something else. Let's try a 6 here and a 1 there. And if there's a 6 and a 1 there, then this would have to be a 2, right? Because this 1 has to also be a part of this Venn diagram, or that part of the Venn diagram. So if we add these, 6 plus 1 is 7 plus 2 is 9, not 8. All right, so that can't be it. Let's try this one more time. Maybe there's a 5 here, and that would make this have to be a 2, which would make that have to be a 3. And in that case, I would have 5 plus 2, which is 7, plus 1 is 8. This is the only scenario that works. If you try putting a 4 here, you'll see that this does not add up to 8. So this is the only scenario that makes sense. And so that your conclusion would have to be that the probability of A intersection B is 2/10 or 1/5. And right now we're just doing this logically and using visual tools, Venn diagrams, tables, things like that. But we're going to introduce a formula tomorrow that kind of shores all this up and makes it a little bit more concise for us.